All right, so we've got Algebra 1 Lesson 5.9. We're going to look at slopes of parallel and perpendicular lines today. So let's do our warm-up first. So again, make sure you guys stop and do the warm-up. Don't just watch me do it. I want you guys to try it first. Okay, so they want us to find the slope of the line segment. So the first line segment is xy, so that's going from here to here. So our slope formula, remember, is y2 minus y1 over x2 minus x1. Okay, so we're going to use our y as our second point and our x as our first point. So I'm going to do 2 minus 4 over 5 minus a minus 3, which is equal to negative 2 over, this becomes a 5 plus 3, so negative 2 over 8, which becomes negative 1 over 4. Okay, so slope of the next line, WZ. So we're going to use Z as our second point, W as our first point. So we're going to do negative 2 minus 0 over 4 minus a minus 4, which becomes a plus here. So we've got negative 2 over 8, which is equal to negative 1/4. So if you guys notice, these two lines right here have the exact same slope. So that's something to keep in mind for this lesson. So we're going to look at identifying and graphing parallel and perpendicular lines, and then being able to write equations to describe lines parallel or perpendicular to another line. And so you guys really want to make sure you know what perpendicular and parallel means by the end of this lesson. Okay, so just to give you a little bit of an example of background, to sell at a particular farmer's market for a year, there's a $100 membership fee. Then you have to pay $3 for each hour that you sell at the market. So $3 is like your slope, and $100 is your y-intercept. However, if you were a member the previous year, the membership fee is reduced to $50. The red line shows the total cost if you are a new member. So you start at $100 and go up by $3 per hour. But the blue line shows what you will be paying if you are a returning member. So you would start at $50 and you would go up still by the same amount, $3 per hour, but you're starting less. So if you guys notice, these two lines here are called parallel lines. Okay? Parallel lines are lines that are in the same plane and have no other points in common. In other words, they do not intersect. So they never intersect, and they have the same rate of change. Rate of change, you guys, you need to start getting in the habit of knowing that rate of change is the same thing as slope. So if you hear rate of change, if it's the same rate of change, that means that they have the same slope. So parallel lines have the exact same slope. For example, the line y equals 1/2 x plus 5 has the same slope of the line y equals 1/2 x plus 1. They just have different y-intercepts. Vertical lines, every vertical line that we come in contact with, they will be parallel to each other. So x equals -2, x equals 4, x equals 5. Any vertical line, they will be parallel to each other. Okay, so which lines in these examples are parallel? Well, we need to find ones that have the same slope. And remember, y equals mx plus b. M is our slope. So we're going to find everything that has the same m value. Well, if we look, these two blue lines right here have the same slope, 5/3, so they are parallel. So the blue lines have the same slope of 5/3, so they are parallel. And then if you guys look, the red lines, they have a slope, even though we don't write it out in front, there's a 1 out in front here, so they have a slope of 1. So they are parallel to each other. So any lines that have the same slope are parallel. Okay, so we're going to identify which lines are parallel in this example as well, but the first thing we have to do is we have to get them all into y equals mx plus b form, because we can't compare the slopes if we don't know them quite yet. So this first line is already written for us in y equals mx plus b. So is the second one. This third one is not, so we're going to rewrite that. 2x plus 3y equals 8. I'm going to move that 2x over. So I get 3y equals -2x plus 8. Divide both sides by 3, and everything by 3, that is. And y equals -2/3 x plus 8/3. And then this last line is not in y equals mx plus b form either yet. So we're going to put that into y equals mx plus b. Remember, that's your slope-intercept form. So 3x minus 9 with my 1 over y equals 3x plus 10. Now, which lines have the same slope? Well, let's look. Okay, this has a slope of negative 2/3, and so does this line up here. Therefore, those lines are parallel. This other line we solved for has a slope of 3. This over here has a slope of 2, so they are not parallel. So the only parallel lines are this one right here and this one right here. Okay, so again, we can only compare slopes if they're in slope-intercept form, or y equals mx plus b. Okay, now we're going to talk about perpendicular lines. Perpendicular lines are lines that intersect and form a right angle. So any lines that form a right angle, they are perpendicular. And the slopes of perpendicular lines have slopes that are opposite reciprocals. That means when they multiply together, their product will come out to a -1. So if you multiplied the two slopes, it would be -1. But all you really have to know is that they have the opposite sign of each other. And then they are reciprocals, meaning that's the flipped, okay? So for example, if I have a slope of 2/3, the perpendicular slope would be -3/2. If I have a slope of 1/5, the perpendicular slope would be -5, or -5/1. If I have a slope that's -7, the opposite is a positive, and then the reciprocal is 1/7, so positive 1/7. So again, two non-vertical lines are perpendicular if and only if the product of their slopes is -1, but I like to just remember this as the opposite reciprocal rule. Okay, the -1 thing can get a little confusing. And just so you know, all vertical and horizontal lines will be perpendicular. So if you have a y equals 3, for example, and an x equals 2, this is your horizontal line, and this is your vertical line. They will be perpendicular to each other. So let's identify which lines are perpendicular. So we've got y equals 3. Okay, so that's a horizontal line. Then we've got x equals -2, y equals 3x, and then we've got to get this into y equals mx plus b form, this last line. So I'm going to distribute that 1/3. Then that becomes 4/3. Okay, so our perpendicular lines are actually, our blue ones are perpendicular to each other because one is x equals -2 and one is y equals 3. So remember, if I have a horizontal and or horizontal and vertical, they're perpendicular. And then the red lines are also perpendicular to each other because if you notice, when I distribute, even if I distribute it throughout, I'm going to have a slope of -1/3, and the opposite reciprocal of -1/3 is 3/1, a positive 3/1, which is the same thing as 3. So these red lines are perpendicular. So now we're going to do some examples with actually using this information. Okay, so in this example, they want us to write an equation in slope-intercept form. Remember, y equals mx plus b. For the line that passes through the point 4, 10 and is parallel to the line y equals 3x plus 8. So we're going to write an equation for a new line, and it's going to be a line that's parallel to this other line. So the other line is y equals 3x plus 8, and our new line is parallel to that and has to go through the point 4, 10. So first we need to identify the slope. The slope of the first line is 3. Well, the slope of a parallel line, remember, has to be the same, so it also has to be a slope of 3. Now we're going to use that slope and plug in this point into point slope form. So y minus 10 equals, we're going to use our slope 3, x minus 4. So there's our point slope form. And step 3, we're going to write it in slope-intercept form. So I'm going to distribute that 3. Then I'm going to move this 10 over. And I get y equals 3x minus 2. So this is the line that is parallel to this original line. And if you notice, they have the same slope. They just have different x-intercepts. Or y-intercepts, I mean. Okay, so here, let's do an example now with perpendicular lines. So they want us to write an equation, same thing, slope-intercept form, so y equals mx plus b, that passes through the point 2, -1, and is perpendicular to this other line, y equals 2x minus 5. So step 1, find the slope of the new line. Well, the perpendicular line has to have a slope that's the opposite reciprocal. So this other line had a positive 2, so this has to be a negative 1 over 2, because that's the opposite reciprocal of the original 2. So now step 2, we're going to write the equation in point-slope form. We're going to use this point and our new slope. So y minus a minus 1 equals our new slope, negative 1/2, times x minus 2. So I'm going to make this y plus 1 equals negative 1/2 x minus 2. So now that's our line in point-slope form, but we're not done. It wants it in slope-intercept form. So I'm going to distribute that negative 1/2. So this will become a positive 1, because when I take a negative 1/2 times a negative 2, that 2 is going to cancel. Okay, so then I'm going to move this 1 over, and I get y equals negative 1/2 x plus 0. And we don't actually have to write that 0 in. We can just write y is equal to negative 1/2 x. That means that it's passing through at the origin. That's why that intercept is 0. So again, you guys, perpendicular or parallel lines have same slope, the lines do, and our perpendicular lines have opposite reciprocal slopes. So other than that, we're just using our point-slope form and our y equals mx plus b form, our slope-intercept form, to solve new equations. The only new information is this perpendicular and parallel slope, and that is all.